All right, welcome back everyone. What we're going to do now, in the previous video we went through and we screened basic assumptions for the single sample t-test. Here we're going to go and run quickly through the primary analyses, as well as calculation some of the auxiliary statistics that we had discussed in class to help bolster our inferences about strength of evidence, things along those lines. So once again, remember we're working with a sample set of data looking at interpersonal difficulties among student survivors of significant trauma, looking at reported interpersonal difficulties among this sample as compared to the normative population of adults. Again, in the manual for this measure, we're seeing a mean score of 25 in adults was reported to be a nationally representative sample. Here we're looking at university undergraduates, and what we're going to do with this single sample t-test is we're going to say the question is are these scores that we've observed among trauma-exposed undergraduates, are they likely to have come from a population with an equal mean to that in the general population of adults? So do we have sufficient evidence to reject the null hypotheses that the actual mean score in the population of undergraduates exposed to significant trauma is equal to 25? Okay, so we're going to go through, we're going to run our hypotheses tests, look at our confidence intervals. Remember, we're going to go through and calculate effect sizes, right? For a single sample or a single sample t-test, this is pretty straightforward. We're just going to take our observed value of the mean minus our reference value over the standard deviation. This is going to give us an index of the magnitude of difference in standard deviation units. Cohen's benchmarks listed here. We're also going to calculate S values. Remember that this is an alternative metric for evidence against the null hypotheses, and we interpret our S value as how much evidence against a fair coin we would take if we were to observe however many successive heads tosses. So if I have an S value of 10, how much evidence would I take that if I were to get 10 successive heads tosses of a hypothesized fair coin? At 10 consecutive heads, I might start to question whether or not that was actually a fair coin. So again, some of this stuff with the S values that we had talked about, and then the Bayes factor bound. This being interpreted as the largest possible odds for the alternative relative to the null based on the data that we've collected here. Okay, so we're here, and in the last video we've gone through and screened IAP total scores for this set of 334. If you recall, we had 70 values with missing cases, so we want to account for that. We had one case with an implausible value of 999. We got rid of that person, and so we're left with 334 individuals in this set. Found that the distribution of IAP total looked pretty good, no extreme values, and so we're ready to go through and actually run our single sample t-test here. So at this point, pretty easy. Again, Stata syntax here, we're just going to run t-test IAP total equals 25. Okay. Again, remember that this was the reference value in the larger population, and so we're seeing whether or not we have enough evidence to suggest that reject the null hypotheses that average IAP total scores in the population of trauma-exposed undergraduates is equal to 25. Okay, so again, here's our output window here. So I'm just going to go through and hit this, run that, and here's our single sample t-test. Again, you can follow this in the handout, single sample t-test. Here's same output that we're getting on the screen right now. But again, working through this, we see that we have a reference value here of 25, right? This is the mean value under the null. So we're testing whether or not IAP total in this sample is equal to value 25 in the larger population. Number of people in our sample. Mean for our set is 39.9. This is standard error of the mean. Our standard deviation, about 20.1. And here's our 95% confidence interval. So based on the data that we've collected, we would say that estimates of the mean IAP score in the larger population of trauma-exposed undergraduates, anything ranging from about 37.7 to 42.0, all of those would be supported by the data. Values within that range would be compatible with the data that we've collected. Now, our point estimate for the population mean of 39.9 is still our best estimate, but again, our confidence interval says that based on the data that we've collected, lower limit of 37.7, upper bound of 42, all reasonable given the data that we've collected here. Wanted to notice that even the lower bound on my point estimate in the larger population is substantially larger than our expected value under the null of 25. So again, based on our confidence interval here, we're saying that 25 is not even close to a reasonable value based on the data that we've collected, right? If we go down, we take a look at our formal test statistic here. We've got a t-value of 13.508 with 333 degrees of freedom. Now, Stata gives us tests for the one-way or one-tailed test in the upper, one-whale test in the lower, and then our two-tailed test. So this is what we're going to be looking at here in terms of our Stata output, and we say we've got a p-value of less than 0.0001. So we're rejecting the null hypotheses here, right? So we say our null hypothesis is that the mean is equal to 25. Here, the one-tailed test, the mean is greater than 25. Here, the mean is less than 25. So again, what Stata is doing is giving you one-tailed test, two-tailed test, one-tailed test. But here, this is what we're going to take a look at. Okay, so we see that our confidence bound doesn't contain, sort of 25 is not a reasonable estimate based on our 95% confidence interval around the mean. We have a very, very large t statistic. All this is leading us to reject the null hypothesis and say that it would be unlikely that to observe these data, assuming that the actual mean IAP score in the population of undergraduates exposed to significant trauma was 25. Okay, but then remember that we want to do some other stuff too to start to quantify the magnitude effect, strength of evidence. So the first thing we want to do is calculate an effect size for this. Okay, now effect size for single sample t-test is pretty easy. What we're going to do here is we're just going to take our observed value, subtract it from our expected value under the null, and divide it by our standard deviation estimate. So for this, we can do this really quickly just here in the Stata command prompt. If I hit display, take my mean value, minus my expected value under the mean, or under the null is 25. That's my reference value here. And I divide that by my standard deviation. I get an effect size of about 0.74. Okay. Again, we could do this by hand using your sort of calculator. It's just kind of easy to run through and just pull this up in Stata as well. So here we get an effect size of 0.74. And so what I would interpret that as meaning, again, based on our interpretive standards, this is going to be a medium to large effect, indicating that based on these data, we're expecting about 3/4 of a standard deviation increase in IAP total scores relative to scores expected in the normative population of adults. Okay, so again, that's quantifying the magnitude of our effect. Other thing that we had talked about in class was the calculation of S values and Bayes factor bound. Both of these, the S value, the Bayes factor bound, what's nice about those and why we've incorporated them is they're just derivations of or sort of nonlinear transforms of your p-value. So here you've got the natural log of your p over the natural log of 2. Absolute value of that is giving your S value. Base factor bound 1 over negative e times your p-value times the natural log of p will give you your base factor bound. Now, issue here is that our t-value is so large that our p-value is sort of being listed as 0 because it's incredibly small, right? We know that the p-value isn't actually 0, but it's just smaller than what is going to be presented here. So one of the things we're going to do, and we'll talk about this in this next assignment, you'll put one of these together, is creating just an Excel sheet that will calculate this for you. And the nice thing we can do with this is we can just get your S values and your base factor bound directly from your t statistic. So here, if I go through and I copy the value for my t statistic, and I know that I've got 333 degrees of freedom for this test, drop that in here, okay? So here's my test statistic, here's my degrees of freedom, my p-value, I'm just using this, deriving this based on, so that Excel will calculate that for you, and put that in, and again, p is still 0, 0, 0, 0, but what we're doing is we're using Excel to go through and calculate both your X value and your base factor bound, right? So your S value is 108, or I guess 109, basically would say that the evidence against the null that we're seeing here would be roughly equivalent to getting 109 consecutive heads in what I tell you is a fair coin. If I gave you got 109 heads in a row, you would definitely not think that that was a fair coin. Here, base factor bound is saying that the likelihood of the alternate, the upper limit of the likelihood of the alternate relative to the null is 2.61 times 10 to the 30th. That's massive, right? So again, these can be difficult to calculate based on your output if you've got such a large t statistic and such a small p-value, but you can do that quite easily here in Excel, and we'll set that up in the next problem set on doing that. Okay. So I think that's about it. If we go down through and we take a look at conclusions, again, this is in your slide. This is just walking through the setup, screening, results, and then your general interpretation. So make sure to go through and take a look at that. Here's a brief write-up for how you would maybe report that within the context of a manuscript, as opposed to sort of a more involved description for our problem sets. But that should get you squared away in terms of running just a single sample t-test. So let me know if you have questions. Otherwise, you should be good to go on this. All right.